Hello everyone, and welcome back to another remote sensing lecture video. And in this lecture video, I want to continue our discussion on errors in remote sensing data by talking about the first type of radiometric error. And so to recap where we left off last time, we had talked about radiometric error as these group of errors that affected the value in the pixel. And so I want to reiterate that point. Radiometric errors are these group of different error-causing mechanisms that make the value in the pixel, right? So the number that's actually being recorded at the sensor to be wrong, meaning that that value doesn't match what's actually occurring on the surface of the Earth. Or in the case of uncorrected data, right? It's not matching the true radiance that should be measured. And so the first type of error we have is sensor errors. So I'm going to spend this video talking about sensor errors. Right, sensor errors. And so you can think sort of at a very broad scale, right, that remote sensing sensors are really not that much different, and in some cases identical to essentially a cell phone camera or a digital camera, right? They have light bouncing off the surface, hitting the camera, and that light's being recorded, right? We've discussed this point ad nauseum. But just like your cell phone and digital cameras, right? These sensors can break, right? They can have one or more of their little tiny moving parts can malfunction. And when that happens, it can impact data quality. And so what sensor errors are, basically just saying is that they're errors caused by malfunctions in the sensor. Right, they're errors caused by malfunctions in the sensor. And this makes logical sense, right? You might, for example, have a sensor where one of the sensing modules for a particular pixel has degraded in quality. And so it's unable to register any radiation, right? So no matter how much radiation that hits that particular sensing diode, right? The sensor is just going to record nothing, right? So you're always going to get a value of 0 coming out of the sensor, regardless of what actually happened. And that's pretty, I don't want to say common, but that's probably one of the most common, is you're going to have single pixel errors. Right, where one pixel, regardless of the image, is going to have maybe a value of 0, or it's going to be reduced, or maybe there's some interference coming from a different part of the machine that's actually introducing more energy than it should, so maybe it's higher. Right, so you get these single pixel errors occur somewhat frequently. But what I want to do here is I want to actually focus on this diagram over here, which is an example of a fairly dramatic sensor error. And this, for reference, is a Landsat 7 image. And what you might hopefully notice immediately here are these black stripes that run sort of at an angle down across the image like that. And these are actual errors. And what happened with Landsat 7 is after being launched, right? Again, we talked about satellite platforms and one of the downsides being that you can't maintain them once they're in space, right? After it had been launched, something called the scan line corrector malfunctioned. And the scan line corrector basically served the role of filling in these lines to make sure that the data was accurate throughout the image. And so when the scan line corrector malfunctioned, what you ended up with these striped lines here of no data. Right? So the satellite was actually giving us imagery with giant stripes, it looks to be, if I were to wager a guess, about a third of the image if you added up all of the areas here, right? About a third of the image is actually now no data, okay? So this is an extreme example. This is an extreme example of sensor errors that is still usable. In some cases, right, if the error is bad enough, you decommission the sensor. In the case of scanline, right, we actually were able to develop algorithms that were able to fill in these gaps with reasonable approximations. And so the question then becomes, well, what do you do, right? How do you fix sensor errors? Well, there's two approaches. Well, there's three. The first is do nothing, right? You just accept that there's an error and you move on. And maybe you make note that a particular pixel has gone bad, so you just keep track of that pixel separately. Maybe you do some sort of algorithm or average, right? Maybe you take the average of all of the nearest neighboring 8 pixels and you assign that value. That's, one option for this would be to try and take some sort of a moving average. Or you take the extreme approach and you actually decommission the sensor. Right? Meaning that we just no longer accept or utilize data coming from that particular sensor. Right? So you can imagine if maybe instead of coming up with a method which we have come up with to sort of estimate these values in these scan lines, if instead we were just like, well, that's too bad, we're not going to put the effort in, we're just going to no longer deal with Landsat 7, right? That's decommissioning. So again, to reiterate, what do we do with sensor errors? We either accept them and just track them through time, saying, okay, this is definitely an error pixel, we're just going to ignore it. We can do some sort of average or algorithm that will attempt to approximate pixel values for areas where we have these errors. Or we simply say, we're just going to throw this whole thing away and we're not going to deal with this sensor anymore. So hopefully this makes sense. This one's pretty straightforward. And if you have any questions, as always, please reach out. Thank you.